All right, now that we've reviewed exponents, let's go over an exponential function. An exponential function is in this form right here. F of x equals CA to the x power. And it goes on to say where a is a positive real number, and a does have to be greater than 0, and a cannot equal 1, and c cannot equal 0. Okay. The domain of f is all real numbers, and that's going to come into play as we start graphing. The domain of f of your exponential functions are all real numbers. The base a is the growth factor. So a is whatever is attached to that exponent. Because f of 0 equals a or c times a to the 0. A to the 0 is 1, so it just equals c, which means that c is the initial value. So example 1, in a protected environment, the population P of a certain endangered species covers over the time T in years, according to the model of this right here. All right, so what is the size of the initial population? Well, the initial value is your C, and C is whatever is in front of your exponential portion. So in this case, 30. According to the model, what will the population of species in 5 years? So this is my T, right? So I am going to have P of 5 equals 30 times 1.149 to the 5th power. So we'll put that in our calculator. 30 times 1.149 to the 5th power. And we're talking about animals or something that's alive. So let's round to the nearest whole species. So this is about 60 species. So now let's change our T to P. No, let's change our T, our time, to 10. So we'll change this now to the 10th power. And we get about 120. So now let's change my P, my T, goodness, to 15. And do you have a prediction as to what this is going to be? Let's see if you're right. You get about 241. So what is happening to the population every 5 years? It's doubling. So this is what makes an exponential and not linear. Linear is going to go up at a constant rate of change or slope. So if it was y equals 30x, it would be 30, then 60, then 90, then 120, then 150. It would constantly go up by 30. Exponentials, though, aren't going to be as constant. It starts at 30. Then it went to 60, times 2 to 120, and times 2 to about 141.